All right, well, let's greet each other properly. Good morning.
Good morning.
All right, this is Mr. Ainsworth, and I'm with my Period 3 class from Great Oak High School. We're going to be in Section 5, where we apply all the trigonometry that we learned in Sections 3 and 4. We're going to apply it to problems dealing with two things. First one is called the angle of elevation, and the second one is called angle of depression. All right, so let's draw some pictures here of what I'm talking about. So let's suppose we have the ground here. Let me do this in black instead. So suppose this represents the ground. All right, just draw some simple diagrams with me. Let's say that at this point here, I'll call it, this is you. This is your position on the ground. When you draw pictures in this section here, you want to draw them really, really simply. I'm talking just very simple diagrams, just noting what's going on. So suppose you're here, and then let's say there's a plane in the sky right here at this position. No need to draw the plane, we just need to know its position here. The angle from the ground to the plane can be drawn as so from you to the plane. This angle right here, from between the ground and between your eyesight, from your eyes to the plane, is what's called the angle of elevation. Let's write that down. It's called the angle, okay, of elevation. Elevation. And if you draw the horizon line from the plane, basically from, if you were the pilot in the plane looking directly straight out parallel to the ground, it's called the horizon line. If you draw that, it would be looking like this, right about here. Draw it parallel to the ground, so parallel to the ground there. We call that the horizon line. It could be, just from your eyesight straight out. So if you're the pilot looking straight out, that's the horizon line. The angle between the horizon line and if you were the pilot looking down at the person at the ground here, that's called the angle of depression. Okay, say angle of depression. Okay, so angle of depression. So one angle is by looking down, or formed from looking down from the horizontal, and then the other angle is formed by looking up from the horizontal, in this case the ground. And the way that I remembered as a kid is that, typically when you go into an elevator or ground level, typically you go up, although you could go down to the basement. But typically, when you use the elevator, you go up, you elevate, you go higher. So angle of elevation is from the ground horizon, or the horizontal, and looking up. To elevate usually means to go up. So think up. When you're depressed, you're down in the dumps. So that's when you think downward. So from your eyesight straight out, that's the horizontal. And then from that, looking down, we call that the angle of depression. So think down, depression, think down. Think elevation, think what? Up. Okay, and that's how you differentiate the two. Also notice in the diagram, if the ground is parallel to the horizon line up here, the horizontal, if they're parallel, the angle of elevation is equal to the angle of depression. Who sees that in the diagram? Back in chapter 3 last semester, what kind of angles did we call those? Alternate angles. So we found that if the two lines are parallel cut by transversal, the alternate angles are the same. So if in the diagrams that we're going to be working with today, in some of the problems, if they give you the angle of elevation, well, you automatically know the angle of depression and vice versa. Okay, because those are going to be congruent. All right, now knowing that, let's go ahead and solve some problems, real life problems. So in example number 1, we want the height of the person to her eyes is about 6 feet. Oh, it's already labeled there. Go ahead and label that. In fact, you know what? Elizabeth, will you turn off the lights, please, in the middle switch, so we can see it better. So the height of the person is 6 feet. The angle of elevation is 22 degrees. Okay, angle of elevation. So think upward here. There's a triangle in here. Let me highlight the triangle so you can see it better. Bless you. Okay, so here's the person. To the trees right here, and then up to the top, and then back down. So there's a triangle in there. Let me highlight so you can see a little bit better on the screen. And the angle of elevation from the horizontal to the top of the tree, it says in the problem, 22 degrees. So we want to label this 22 degrees here. That's called the angle of elevation, from the horizontal up to the top of the tree. Okay, and then it says here, and the distance from the person to the tree is 40 feet. Distance, 40 feet. So this distance here from the person to the base of the tree is 40 feet. The question is, and I forgot to write it in the problem here, is what's the height of the tree? Okay, h is height. Okay, so h equals height of the tree. What is that in this problem? Okay, and I know we don't know that, but we're going to find it. So what you do is, we're going to have to assume that the tree is perpendicular to the ground, first of all. That's our first basic assumption, even though that's sometimes not true in real life, because not all trees are perpendicular to the ground. Sometimes they grow out on an angle. Yeah, those crazy trees are on an angle. We're going to assume that this one is, because we need to form a right triangle here to use our trig, because our trig that we know, the sine, cosine, and tangent, only deal with right triangles. So check this out. If the person, the height from the ground to her eyes is 6 feet, then this also is 6 feet. All right, those are the same because the horizontal is, well, opposite sides in a rectangle are the same. So if one side's 6 foot, then the opposite side's 6 foot 2. This distance here is unknown. Let's give it a name, like x here. That's unknown. And hopefully you see in the diagram there that the height of the tree is the sum of the two distances, 6 plus x. Who sees that in the diagram? If you know what x is, you have to add 6 to it to get to the height of the tree. So h is equal to whatever x is plus 6 more feet. So hopefully it's obvious at this point that we need to find x. And we're going to use the triangle to help us because we understand what trig is all about. Okay? Now, if the distance from the person to the base of the tree is 40, then this is also 40. So we know the adjacent side of the angle there. We know that that's 40 feet. 40 represents the adjacent side. What does x stand for that's farthest away from the angle? Everybody say it? Opposite. Okay, so what function deals with opposite and adjacent? Okay, everybody write down SOHCAHTOA again. SOHCAHTOA. In this problem here, we have the opposite side is x and the adjacent side is 40. That calls for the tangent function. And we understand and remember that the tangent is the opposite side divided by the adjacent side. So what am I first going to do is I'm going to set up the problem. I'm going to take the tangent of my angle, 22 degrees. I'm going to set it equal to the opposite side, x, divided by the adjacent side, 40 feet. That's the setup. And in your homework, I want to see the setup every single time. I want to see how you're solving it. I want to see how you're using the calculator. I want to see all 3 steps. Okay? Now, we want to solve for it first, and since x is being divided by 40, we're going to multiply both sides by 40. That's my process. 40 divided by 40 is 1 on the right, given my answer being 40 times the tangent of 22 degrees. At this point, you want to get the calculator going here. We're going to do it the modern way. We're going to take 40, and work with me on your calculators, everybody. Verify your work with mine as we go. I'm going to take 40, and I'm going to multiply it by the tangent of 22 degrees. And I'm going to look at that decimal here, and I see we're going to round it to the nearest thousands like we always do in class. We're going to take 16.161. We're going to look at the 0, the 4th digit, and round the 3rd. Because it always goes tenths, hundredths, thousandths. So the 1, the 3rd digit, is the thousandths place. And if we're going to round the nearest thousandths, we've got to look at the 4th digit and round the 3rd. Give me a thumbs up if you're with me on that. We look at what digit? 4. The 4th and round the 3rd. And that's the nearest thousandths. So this is going to be 16.161. Let's record that. 16.161 feet is approximately equal to x. Now, because I rounded, I say approximately equal to. It's not exact, it's rounded. And then to find the height, I have to add 6 more feet because the ground to the person's eyes is 6 feet. So 16.161 plus 6 more gives me approximately 22.161 feet. By the way, do you guys understand this abbreviation right here, the apostrophe? Yeah. What does that represent? What does the double apostrophe represent? Inches. Very good. So the single apostrophe is feet, the double apostrophe is inches. Just making sure that everybody has seen that symbol before. Your choice. You can go apostrophe or you can go FT for feet. It's your choice. All right, now that's one application of the trig that you're learning. There are many others. So let's take a look at this one. This one's cool because I've actually been to Lake Powell before when I was a teenager, when I was your age. It's one of the biggest lakes in the local 500-mile radius of us. And anybody, raise your hand if you've been there before. Wow, I have 3 or 4 people, 5 people. It is a huge lake, very, very beautiful. And it has this arch somewhere on this lake. I've actually seen it. I've actually been underneath it, and some people actually climb it up to the top. It's a pretty, it's like a miracle. It's this awesome sight. Well, so in this problem here, we want to find the height of the arch. So we're going to call that h. No, actually in the problem it's called x. So let's call that x. It's right here. And x is the height of the arch. And you'll notice that this little piece right here, it's labeled 5 feet. Well, that's because this distance is 5 feet as well. So the distance from the ground up to that measuring device, this little measuring device, you'll see people out in the streets, they're called surveyors, use this device to measure angles of elevation and depression, and also distances now, because they have infrared devices and they can measure distance with that. It's called a sextant. At least it was called a sextant back in the day, or a theodolite. I'm not exactly sure what the modern term is, but it's an old device used to measure angles, and in this case the device measures the angle of elevation as 48 degrees. Okay, that's called the angle of elevation right there. Angle of elevation. So using that device, you're able to calculate the angle from the horizontal all the way up to the top of the arch. Okay, and let's suppose that angle is 48 degrees. The distance from that device to the point directly underneath the arch can be paced off and measured. That's 36 feet, and so on. So we have the height right here, the height of the arch. We'll call that h. And who sees that it's similar to the last problem, the tree problem, in that the height of the arch is whatever x is plus 5 feet. Who sees that in the diagram? The height of the arch is whatever x is plus 5 feet. So let's write that down, x plus 5. So it's obviously, or it's obvious hopefully, that we have to find x first using this triangle in here. So let's take a look at the triangle. Let's label the sides and decide on what function we're going to use. So what you do is your eyes should be right here at the device. You're at 48 degrees, and you go straight across. Opposite of the angle is x. This is the opposite side, OPP for short. And what does the base of the triangle represent at 36 feet?
Adjacent.
Adjacent side. Now, what function deals with opposite and adjacent?
Tangent.
Okay, toa. Okay, we're going to use a tangent function in this case, because the two sides that we're working with are opposite and adjacent, and that always calls for the tangent function. So once again, let's set it up. Take the tangent of 48 degrees. By the way I write it, there's only one correct way, and it's exactly how I'm writing it. No other way is correct. So make sure when you take notes, you're detailed and you write it just like I do. If you switch the order between the function and the angle, it's not correct. If you switch the order of the ratio, it's not correct. So make sure it's exactly written well. Okay? And that's going to be equal to the opposite, which is x, divided by the adjacent, 36. Now speak up if you have questions, because I don't want to go too fast and I don't want to lose you. At this point, there's your setup. To solve for x, we got to multiply both sides by 36. Show simplifying there. 36 divided by 36 is 1. Let's go to the calculator. Let's take the 36 times the tangent. 48 degrees. And let's round this to the nearest thousand. So I'm looking at it, I'm thinking 39.982. So 39.982, and you put the units on there, which are feet, is approximately equal to x. Well, we're not done with the problem yet, because we're looking for the height of the arch. So what do we have to add to x?
5 feet.
To add 5 more. So h, the height of the arch, is 982 plus 5 more. So h is approximately 44.982 feet, and this is the height of the arch. Okay? Any questions up to this point? Alright, well, let's experience another one. This one here, I'm going to have you guys draw. I'm going to pause the video right now, and I want you to read the problem. And as you read it, I want you to draw a picture on the left-hand side. I'm going to walk around the room in just a minute. and then I'm going to come back up here, and then I'm going to draw it, and well, let's see if your diagram matches mine. That's part of the skill, by the way, because not all problems are drawn for you, so you have to learn how to diagram it yourself. And when you diagram a problem, make it simple. If I'm talking really, really simple. Okay. Now the theodolite, just to let you know, that's that measuring device that I was talking about back here in this problem here. It's the device that measures angles. All right. So when you draw a picture of this, you don't have to actually draw it because you don't know what it looks like. You just plot points, and like I did, plot a point for the position. Draw the ground, draw the building as a rectangle, draw some simple picture. So I'm going to pause the video, I'm going to walk around and watch you do this. Okay, so here's the ground. Ground, okay, surveyor stands 200 feet from a building, so I need to draw a building. And the surveyor stands 200 feet from the building, so I'm going to put the surveyor here. This distance right here is 200 feet. And he stands with a theodolite. So let's just say the theodolite, the thing that he's holding is right here, and it's 5 feet high. So it's 5 feet high. The angle of elevation from the top of the building is 35 degrees. So here we go. Watch this. I'm going to put the triangle in red. Here's the horizontal. Here's to the top of the building. And here's the angle of elevation, 35 degrees. So, and here's the triangle that you're going to be working on right here. It was pretty close. Okay. Now we got to put in some unknowns. First of all, this is 5 feet right here. So that's 5 feet, and then this is 5 feet. Who put a 5 right here? Okay. This part right here is unknown. So let's call it X. That's unknown. And the height of the building is unknown. We'll call it H. And who sees now that H is whatever X is plus 5? H is whatever X is plus 5. So let's write down H equals X plus 5. We know that, but we got to find X first using the triangle. So since the distance from the person or the piece of equipment called the theodolite is 200 feet from the base of the building, that means the base of the triangle is also 200 feet. Now, what side does 200 represent on the triangle in respect to the angle 35 degrees?
Adjacent.
What is it?
Adjacent.
So it's the adjacent side. And opposite of that is x. What function are you guys thinking of?
Sorry.
Say it again?
Tangent.
Tangent function. So katoa. We're going to use the tangent function. So let's set it up. We got the tangent of our angle, 35 degrees, is equal to opposite x divided by 200 this time. That sets up the problem. We have to multiply both sides by 200 to isolate the unknown. So let's go ahead and do that. And then we have to take 200 times the tangent of 35 on our calculators. And I noticed that around the classroom you guys already got to that point, so that's good. What'd you get? Okay, so let me verify that. So we got 200 times the tangent of 35, and I agree with you. Okay, 140.042. So 140.042 feet in this case is approximately x. But to get the height of the building, you have to add 5 more, so you get 145.042. So the height is 140.042 plus 5 more, approximately equal to 145.042 feet. Did we get it? Good for you. All right. All right, let's try another one. Last one. This is the plane problem. So we got an airplane flying 3,500 feet above the ground. That's the altitude. Begins a 2-degree descent. Now what's descending mean?
Going down.
Okay, is that angle of depression or elevation?
Depression.
Depression. So from the horizontal, from the plane, is a 2-degree angle. And then it begins a 2-degree descent to land to the airport. How many miles from the airport? Ooh, how many miles? miles from the airport is the plane when it starts its descent. So let's draw a picture here. Let's draw the ground. Let's say the plane's right here. P for plane. Okay, airport over here. A for airport. Okay, there's the plane's position right up there in the air. It is 3,500 feet. 3,500 feet above the ground. And it's going to start a 2-degree descent. Now, 2 degrees, if you draw it to scale, would be kind of difficult because you wouldn't be able to do it on this piece of paper because it's a 2-degree angle is very, very small. And if you don't know what I'm talking about, let me just show you right here. If I draw a segment from the plane to the airport and then draw also the horizontal from the plane, here's the horizontal. This is the horizontal. These are parallel. A 2-degree descent is right here. But that's obviously much bigger than 2 degrees. That's more like around 35 degrees. If I draw an accurate 2-scale drawing of a 2-degree angle, it'd be so small that I wouldn't be able to draw the triangle because it'd be way off the paper. So on this problem here, this is not the scale, first of all. Because you can't draw it to scale. But you don't need a perfect drawing to solve this problem. You just need to interpret correctly. So we got a 2-degree angle of descent that's right here. It's called an angle of depression. Angle of depression. Remember, angles of depression look down, not up. Okay, when you're pressed, you're down. Okay, so think down. Who also sees that this angle here is 2 degrees? Who also sees that? What type did we call them back in chapter 3? Alternate interior, and they're congruent when the lines are parallel, which they are, because the ground's horizontal with the line of sight from the plane. And then it says, hey, how many miles from the airport is the airplane when it starts its descent? So right here on the ground, this is where it starts its descent. Starts descent. So the question is, how many miles is this? How many miles? Not feet, but miles. And notice that the height is in feet. So we're going to solve for x in feet, and then we got to figure out how to convert feet to miles. And it's not that hard, but we'll do that together one step at a time. So put the right angle in because altitudes or heights are measured perpendicular to the ground. We have a right triangle there. Opposite of 2 degrees is 3,500, and adjacent is x. So what function are you guys thinking of? Okay. What function? The tangent function. Okay, the tangent function again. So let's set it up. We got tangent of a 2 degrees this time, very small angle, is equal to the opposite side, 3,500 feet this time, divided by the adjacent side x. And this time, it's our first time we've seen in this lesson, the variable's in the denominator, which we don't want. We don't want in the denominator. Okay, so we can't multiply by 3,500 feet because then we'll get 3,500 feet squared.
X.
We multiply both sides by x in this case. You always multiply by the denominator to clear your fractions. Okay, you always multiply by the denominator to clear your fractions. So that's step 1. We get x times the tangent of 2 degrees is equal to 3,500. We're still not done yet. Isolating the variable. What's step 2? That's right. Divided by the tangent of 2 degrees, both sides. Okay, show your canceling, show your simplifying. At this point, we use our calculator and we take 3,500 divided by the tangent of 2 degrees, which is going to be a big number. So 3,500 divided by...
We're still going by the thousands? We're still not done.
Yeah, we're not done yet. Let me type in tangent of 2 degrees here. There we go. Who's coming up with 100,226.887 feet? I told you it's going to be a big number because the plane's far away. So 100,000. Yep. 226.887. So 887 feet. Okay. Now the question, I heard a question in the back. Hang on. The question is, why is it in feet? And the answer is because the height, the altitude, is in feet. And if the height is in feet, then x has got to be in feet. But we want the answer in miles. Question? That's right. So who knows how many feet in a mile? Yeah, let's write that down. 1 mile equals 5,280 feet. So what you have to do on this problem here is you have to multiply it by a conversion factor. Since 1 mile, there's 1 mile per 5,280 feet. Okay. I don't know if you guys know this, but units cancel out just like numbers do, and you should see this in chemistry and physics classes. It's called dimensional analysis. Feet divided by feet is 1, giving you miles. And I heard someone say out there in the audience that you divide by 5,280, and the answer is yes, because it's in the denominator here. Now this number, the 100,226, is already entered in the calculator. So all you have to do is divide it by 5,280, get a number, and it tells you how many miles it is. So let's divide it by 5,280, and you get about 18.982 miles. So 18.982 miles from the airport once it starts its descent. Okay, now your problems today in this lesson are all application problems. They're done just like this, so have your notes side by side with your homework when you do it. You do 8-5 tonight, and we're done with the chapter, and we start reviewing tomorrow. And I'll see you tomorrow.